we want to find the volume rotating about the y-axis bounded by y equals x and y equals x squared using the shell method. So we certainly need to draw this graph. And the nice thing is when we're revolving about the y-axis like that, these are a little easier because you're going to pretty much use this formula. My limits are going to be my limits of my x values, and then 2 pi my radius, which you're going to see when I draw this, but it's going to be x, and then times my function. The only time this really changes is if you have two functions like this, and I kind of have to get the difference between the functions. So let's do it. If I graph y equals x squared, that looks like kind of sort of y equals x squared. And then I also graph the line y equals x. Pretty good. And I'm rotating this about the y axis. So this is really what I'm doing here. I could draw something like that, and then prepared to be astonished with my drawing skills. So basically what I'm doing is I have this shell in here, and I'm drawing like that. It's going to look something like this. Okay, I know, a beautiful drawing, right? But the key is you have to be able to find these values and understand, well, how in the world are they finding the radius? Well, my radius then simply is going to be from here to some x value. I don't know what x value, so let's just call it x. And so I also need my limits of integration, which I'm looking at from 0 to whatever this value is. Well, these functions would meet if x is 1, 1 squared is 1, y equals x, 1, 1, get it? So it would be at 1. And so I have coming down here, my volume equals, let's chunk the 2 pi out front, from 0 to 1, my radius is x, and now the height, and that's what this is. This is my height. I don't know, can you see that? Yeah. And this is my radius. So my height in this case, normally it's just your function. But since I have two function, I take my top function, which is my booyah, my x, and I subtract it from my booyah, you gotta say booyah, my lower function, which would be minus x squared, and now we're home free. Now it's pretty easy to solve this because now we just do our antiderivative. So get on this side so you can see me. Our antiderivative, I throw the 2 pi out front. I'm going to distribute this, so that becomes x squared minus x cubed, right? So down here, how do you find the antiderivative? You remember, we add 1 to my exponent, and that's also the denominator, so I get x to the third over 3 minus x to the fourth over 4, and I'm evaluating this from 0 to 1. So I just simply plug in the values. If I plug in 1, that becomes 1 cubed, which is 1, 1 to the fourth, which is 1. And you really should get into a habit of doing this. I know that this is 0, but the problem is students get out of that habit because remember what this is, the fundamental theorem of calculus, right? That I can do the f of b minus f of a. So you really should stay in a habit of plugging these in. Yes, I know that goes away. And so then this piece right here becomes 2 pi. I'm having to get my common denominator, so I'm going to cross multiply. So 4 minus 3 over 12. You like how I did that? Good, right? So common denominator basically is what I'm doing. So this becomes 2 pi times 4 minus 3, 1 over 12. 2 goes into 12 6 times, and I get my final answer. So once again, as I mentioned in the video before, when you rotate about the y-axis, these are pretty easy, because this is probably the only hard part, is if you have more than one function, but then your radius, you're just going out to some value, we're going to call it x. There you go.